What's up, Frank?
Hello.
Hey, nice hair.
Thank you.
All right. So what do you want to go over today?
Yeah, okay, the breakout again. I'm failing right now.
You're failing right now.
Yeah, I'm
What?
failing right now.
What?
Yeah.
What class?
Wait, hold on. I'll put my school out there. Hold on.
Got it?
Yeah. So basically like the wait, hold on. The unicircle, like they're reading right now.
Yeah. The units are.
Yep, and we just finished it like chapter 4 or whatever, and then it was like all about. And the teacher told me like the chapter 5 is gonna be like gonna be like the hardest one, and like inverse trigonometric functions and the graph of sine and then cosine functions or like tangent, like all those kind of stuff.
Oh, okay. Yeah. Like arc sine, arc tangent, arc sine. No, secant,
Yeah, cosecant, like yeah,
and arctan.
like everything.
So, you finished with the unit circle. Are you got and the next unit, which is the one that you're currently working on right now, is going to be is over the graphs of sine, cosine, tangent, secant, and cosecant, arctan, right? Is that correct, or am I missing something?
Yeah, I mean basically that's what we just went over. I'm pretty sure like because yeah, and I don't know, like I'm not sure. Wait, hold on. I can tell for sure. Just give me like a second.
Yes. Only got 30 minutes though, so.
Oh yeah. All right. I mean, can I use like the example, like the questions like that I have on my homework?
Yeah, well, for the next unit, or for whatever you don't understand.
It's like I don't know, like basically like the chapter like itself. It's kind of like hard to me. That's I'm failing right now.
The chapter
Like,
itself.
yeah, like the chapter, like the word, like the cosine, like I know like the like the basic stuff, like whatever like talk about in the beginning of the the entry like the chapter, but like when get deeper. Like, for example, like the graph, like I have to find like,
Okay, well, here, do you understand the unit circle first?
I mean, like I cannot like tell like 100%, but like I do like what is this for in the year.
Okay. Well, the first thing that you're gonna need to do, okay, when we get off this call, is memorize the unit circle. It's very important.
Yeah, like so. I mean, she's at least she's letting us using the unit circle during the test. So
Oh, okay.
yeah.
That's even better.
Uh-huh.
Um, so here's, let's say this is the unit circle, right?
Right.
What it shows you is the values of sine, cosine, and tangent, um, based on where you are on the circle, right? So you
Right.
have the inside is in rate is in degrees. So 30 degrees, 45, 60, 90, 120, 30, 135, yada, yada,
Right.
yada, degrees. And the outside, pi over 6, pi over 4, pi over 3, pi over 2, that's in radians, right?
Right.
So the unit circle, the basis of this is the distance from the center to the outside is 1, a circle with the radius of 1, which means the hypotenuse of the triangles that you're creating are always going to be 1. Okay.
Yep.
And your sine value is how high you go, is your y coordinate, and your
Right.
cosine value is your x coordinate.
Yeah.
Okay. So you really, when you're doing the unit circle, you only have to find the actual values of
Yeah.
this first quadrant, like the square root, like pi over 6, pi over 4, pi over 3. If you know those, you can find all of the other ones very simply based on just changing the negative signs, right?
Right.
But like you recognize that close to the like pi over 6 and 5 pi over 6 are the same, just with a different sign on the x coordinate.
Hmm.
And 7 pi over 6 and 11 pi over 6 are the same with the different sign on the x coordinate. And the same thing vice versa. You can just, if you look at it, you can recognize the pattern. But basically, you only need to memorize this first part if you're going to memorize it at all, which I don't think you need to because you're given it.
Yeah.
That being said, what they want you to use this for is when you have a circle and you have sine 30, it's going to equal something, right? Well, rather than plugging in the calculator and finding what that is, what is it?
So sine is like object. All right. Wait. Opposite over hypotenuse. So
Well, this is a unit circle value, right?
wait, hold on, maybe. Wait. So pi over 6? Is that what you're asking? The
Yeah.
answer?
What's sine of 30 degrees? Or sine pi over 6 is the same thing.
Yeah. Uh, oh yeah. So yeah, they are basically same. The value.
So what's the value?
Um, you're asking like the point, like square root is 3/2 and then 1/2.
Okay, but I'm asking for the sine value. So you gave me the coordinate on the unit circle.
Okay.
And I said the x value is one thing and the y value is the other thing. So what does the
Right.
x value represent?
Oh, wait, 180. No, wait, hold on. So 180. No,
No.
wait,
Um,
wait. So you said x
so
over 6 in the
so you
parentheses,
you
right?
you gave me that it was square root 3/2, 1/2,
Right?
right?
1/2,
One
yeah.
of these values is sine, and one of them is cosine.
Oh wait, first one is sine, the second one cosine. X
No.
is x.
X is cosine, y is sine.
Oh, Okay.
A
X is
good way of
sine, X is
remembering
cosine,
this,
and the Y is sine. Okay.
a good way of
Hmm.
remembering this is you have your unit circle, right? And you
Yeah.
have 1 comma 0 at um at the like when there's no at 0 degrees, right?
Right.
The at 1 comma 0 at 0 degrees, it's cosine. At 90 degrees, it's 0 comma 1, which is
Right.
sine. That means sine is at 1 here and cosine is at 1 there.
Mm. Yeah. I see.
Okay.
Yeah, I see them.
So that means sine is 1/2 at 30 degrees. What about tangent? What is tangent at 30 degrees?
Tangent is really. Oh wait, then square root 3/2.
Square root 3/2 is
Yes,
what again?
that's cosine.
Okay. And
Oh, it's
what is tangent?
tangent. So it's tangent. So yeah. Um, wait, cosine is sine, and then tangent is gonna be
What's the formula for tangent?
wait, opposite over hypotenuse. Yeah, wait, I can't pronounce it.
Opposite over
Hypotenuse,
hypotenuse is sine.
hypotenuse.
That's
Wait, so
sine.
uh, oh wait, hold on.
You think of this, right? So,
F Jason. Like yeah, opposite of F Jason.
yep. So
Yeah,
Katoa,
so
right?
got to yeah, I was like, yeah,
Yeah.
I'm
I was trying
tripping.
to teach Cindy this too, and she just didn't understand. But yes, so Katoa. So it's opposite over adjacent. Another way of writing this is tan is equal to sine over cosine,
Mm,
right?
yeah.
So if tan is equal to sine over cosine, and you have cosine and sine, how do you
All
get
right.
tangent?
Just sine over cosine, and then that's tangent.
Okay. So what is tangent of 30 degrees?
Okay. So sine is wait, hold on. Sine is over two. Square root 3.
Yeah, I think so. 1/2 over root 3/2. Actually, no, it's 1 over root 3.
Wait, I think yeah, I think I did the like the flipped it over whenever I tried. Yeah. So
Yeah.
1 over square root 3.
Yep. So or root 3/3. But yeah, that is tangent of 30 degrees. Okay, that's the basics of the unit circle. Does that make sense?
Yes.
Okay. Now you want to know how to arc sine, arc tangent, or sorry, secant, cosecant, and arctan, right?
Secant, cosecant, they're like, isn't there like the flipped over of the cosine, sine, and
Yes.
tangent?
So our secant is equal to 1 over cosine. Cosecant is equal to 1 over sine.
Sine and
Wait. Cosecant is the reciprocal, yeah, sine. It's been a while. And arctan is the inverse of tangent.
right.
Right? So if I said the secant of 60 degrees, what would that be?
That would be 1 over two. Wait, cosine is the 2 over square root 3. No, wait, so wait, 2 over square root 3.
2 over square root. Okay, so secant of 60, right? 60
Wait, it's
degrees.
60. Okay, 60. So 2.
Yeah, 2.
Uh,
What about arctan of 5 pi over 6?
10 of 5. 5. That's gonna be 150 degree and mm, here is 3 over 3.
Square root 3 over 3. Yep. Well, wait. Are you sure?
Negative square root 3 over 3.
Yeah.
Yeah.
Okay. Just remember, don't forget your negative signs because of the like
Oh yeah. Yeah.
the angles matter for that.
Right.
All right. So quickly we'll go over graphs. Okay, so have you ever seen the graph of cosine?
I'm pretty sure I did, but but I to be honest, like I don't really remember like how it looks like.
Okay, so let's logic it out, right?
Okay.
So at 0 degrees, so we have 0 degrees, pi, and 2 pi. At 0 degrees, what is our y value?
Oh, at 0 you realize what
Or what is
Zero?
cosine? No, what is cosine at 0?
oh 1
Yeah, yeah, 1.
1
So what about at pi?
-1.
Yep, -1. What about at 2 pi?
What about what? 2 pi?
Mhm.
Oh 1.
1.
Oh yeah, it was swerve.
Okay. And then let's go pi over 2 and 3 pi over 2, just to make it a little bit more points.
Oh,
What
I remember now. Yeah, like it's going up and
what is
down. Like swerve.
yeah, but what is cosine at pi over 2?
Cosine and pi over 2. Um, 0.
And then 3 pi over 2?
That would be 0.
Yep. So you're right. It's gonna
Oh
swerve
yeah,
down
I remember. I remember.
and then come back up.
Yeah.
And this keeps going on forever and ever.
Yeah.
So this is cosine.
Oh yeah. And the sign is gonna be like
Yeah, let's do sine.
the opposite way, right? Like going up and down, like the opposite of the
Yes, but
yeah.
I want you to logic it out and come to where the answers are
Okay.
going to be. So at 0, what is sine?
At 0, sign is 0.
Okay. At pi over 2?
1
At pi?
0
At 3 pi over 2?
-1
At pi? 2 pi?
0.
Yep. So if you go like this,
Yeah.
so it's oscillating at a different frequency. If you
Right.
shift it over, it will be the same as the other one, basically. That's basically the difference between sine and cosine. All right. Now let's do tangent. Tangent's a little different because of how it works. Because you can't have like 1 over 0. It's imaginary, right?
1 over 0 is
So where is it imaginary?
nowhere.
Nowhere.
Because like it's imaginary. It's not
Okay.
exist though, isn't it?
Well, okay, fair enough. Where's the asymptotic, I should say?
Oh,
Like what?
asymptote.
Where's the asymptote?
Is it the like asymptote? Um,
So remember, what is tan equal to again? In
say
terms
it.
of sine and cosine?
Sine and cosine.
Yeah,
Tangent equal sine over cosine.
correct. So
Wait,
if
so
if one of the values is 0,
yes,
the if so so if the value of which of these is 0, the whole equation will be 0, sine or cosine.
either one.
Huh?
Oh wait, sine and cosine.
If it equals, when does tan equal
Cosine,
0?
cosine.
If it's sine over cosine, which of these will make tan equal 0? Is sine 0 or cosine 0?
I mean, either one, isn't it?
Well, if it's sine over 0 and you
Yeah.
have 0 over cosine, what's 0 over cosine?
Oh,
Nothing over something,
so
right?
cosine. No, sine, sine.
Okay, wait. Hold up now.
Wait.
Let's just think about this.
Okay.
These are the two functions that you have plugging
Right.
in for 0.
Right.
One is an asymptote, one gives you asymptotes,
Yes.
and one gives you zeros.
Yes.
Which one gives you zeros and which one gives you an asymptote? Choice 1 or choice 2?
One gives zero and the two gives asymptote.
Asymptotes. And this one gives you?
Oh, first one is asymptote, the second one is zero.
Correct. The reason
Oh,
is if you have 0 over anything, right?
okay.
0 over 1, that's 0, right?
Oh yeah, that's zero.
0 over 100 is still 0. If
Okay.
you have 1 over 0, that's a little different because you can't have something over nothing. How can you have, if I'm taking your grapes and you
Right.
have no grapes to begin with, how can I take your grapes? It doesn't work.
Oh, okay. Okay.
So
Oh.
that's why this is an asymptote. So
Oh.
whenever cosine equals 0, you have asymptotes, and whenever sine equals 0, you have zeros. So sine equals 0 here, here,
Oh yeah.
here, and here. Cosine equals 0 here, 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 and here.
Oh yeah, it was like vertically. Yeah. I remember.
Correct. And then if you do the same thing we did before for tan, you get this. Kind of looks
Oh
like a
yeah,
cube
that thing, yeah.
graph. Okay, that's our tan graph. Now we got our secant
Cosine,
graph, which is the inverse of cosine, right?
right?
So 1 over cosine, if you have cosine equals 0, you have an asymptote. So cosine equals 0 at the same parts we did before, right? But cosine won't be negative in the, unlike tan, where it's sine over cosine, secant is just 1 over cosine, which means if you plug all of these values in,
Yeah.
You get graphs that look like this.
Oh, up and down, up and down.
Have you seen these before?
Yeah, I've seen it before.
And then, yeah. So they look like that and they go on forever. Secant. Oh, sorry, that's secant. Cosecant is the same thing, exact same thing as secant, but just shifted. So instead of being on on this point on your cosine graph, it's now on your sine graph. And the asymptotes have also shifted. So instead of being on your zero of your zero of your cosine, they're now on the zero of your sine. So you have 0 there, 0 there, 0 there. Then you have this going up there, and this going there, and then this going there, so on and so forth.
Mm.
What it looks like, if you look at all those graphs in total, you get something like this,
Yeah.
right?
Yes.
And you also have cotan or arctan, which is
Yeah.
the same thing but inverted. Does that make sense?
Yeah.
Okay. Now, okay. So I have explained to you the basics of graphs, secant, cosecant, cotangent, and the unit circle. Are there, and we're almost out of time, so are there any last minute questions that you have if you don't understand something?
Um, I'm pretty sure I do, but like, can't really find like it. Because I know like how to find like the A and B, like the period, like the point and the amplitude as well.
Oh, you're talking about the shifts of the graph, right?
Um,
Or is something else?
that's like I mean, I'm not sure it's the shape of the like the graph, but like the amplitude, say like y equal a sine x and y equal a cosine x, and represent the half the distance between the maximum and the minimum values of the function, and it's given by that's the amplitude. That's what it says over here. The definition of the amplitude.
Yeah,
So yeah,
I think that's just
yeah, like just like the maximum, like the minimum, and like just find the like
yeah. But
yeah,
you okay?
the
So
distance.
you saw how to do that though, right?
Yeah.
Where you have check when if the denominator equals 0, it's an
Right.
asymptote. If the numerator equals 0, it's 0.
Yeah.
Remember, if you want to find the maximum of something,
Yes.
try to find the point where it equals 1.
Mm-hmm.
That's going to be your maximum, or 1, or whatever the shift is for your cosine and your sine graphs. For your cosine and your sine graphs, wherever they equal 1 or whatever the shift is, that's going to be a maximum.
Okay. Okay.
Whenever your minimum for your cosecant and your secant graphs are going to
Right.
be that same, the maximums of your sine and your cosine graph,
Yeah.
right? Because these go up to infinity.
Mm.
That's going to be your relative minimum and your relative maximum, depending on what part of the graph you're in.
Okay.
Your tan graph and your cotan graph are going to be a little different. You got, this goes up asymptotically forever, right? And so you don't have a relative max, relative min. They're just going to approach an asymptote. Whatever that asymptote may be, you just have to figure that out based on the equation that they give you. All right. I
Okay.
think that covers our time for today.
Yeah.
I hope that helped a bit.
Mm-hmm.
Okay. See you
All
later,
right.
Frank.
Yeah. Thank you.